Okay, those who just came in, please log into LMS, download experiment 6. So we're going to go back to Cisco Packet Tracer. Do you remember the first experiment that we did in Cisco Packet Tracer? Yeah, and I hope still you have the, it's not like you spent long working with it. I hope as teams you have done your DA1 in Cisco Packet Tracer, right? But if you remember the first lab that we did on Cisco Packet Tracer, what did we do? Do you remember that experiment? In fact, we were trying to emulate this lab setup. Yes or no? So what was the thing? It was like an isolated LAN that we built. What was the topology you built? Star topology, right? And what was that central device that you see there? The switch. We understood how the switch functions, and that's one physical network. This is one physical network where you can locally communicate to any systems within this LAN, right? That's an intra network. So within your LAN, no lights are on. What's the name? Oh. So we had set up, I think, more than the theory and the lab, with extra theory. That's good. Anyway, okay. So, but that was just the LAN, right? Where it was like switch handles your delivery of your packets. But then now, can we get on looking at more beyond layer 2 device in your LAN? We will look at how inter-network communication is possible. Can we do that? So what do you mean? We're going to build several separate networks and interconnect these networks. Yeah. So we're going to communicate from one LAN to another LAN. I say imagine you have several campus of VAP. You want to internetwork these separate private networks. And I want you to imagine that in your home you have your Wi-Fi router. Yes or no? All of you look at the backside of your Wi-Fi router. So what are the ports you see in your model of your Wi-Fi router? You see some Ethernet LAN ports, right? But then have you ever used for your internet, LAN setup within your home using Ethernet? I think probably you directly connect with your systems with a Ethernet connection. But then you could expand, right? You could have multiple networks connected to your router. But if you want to connect to external network or your internet, it is possible through your ISP who is providing you a service. There's a fiber line that comes in, and it is connected to which port? LAN ports are one way, yeah? But then you are all connecting through your Wi-Fi connection through the router. But then you want to get connected to the internet. There was one port through which your fiber line runs. That's called the WAN port. What does the WAN port stand for? Wide area network, right? So this wide area network is having this communication and ensuring that your data travels from your network to outside network. But on the fiber line in the focus, right? Where does it go? How does it get connected to the outside core networks? Right? How does your data travel through intermediate routers? So let's now try to emulate a small setup. I'm going to take you through this concept of how we allocate IP addresses, having understood classful blocks, classless blocks. We have understood how we could do subnetting, right? So in the very IP address allocation aspect also we look at, we'll also understand how the packet routing process also could be implemented. Can you do that? Are you all ready? Those who joined late, I want you to get into Cisco Packet Tracer. So this session I'm also recording. So I want you guys to first look at the setup that we're going to do. Let me draw and show you what is this setup ideally. So let's imagine that we're going to build, say, three separate LANs. Okay? So we're going to build three separate LANs. And let's build these three separate LANs based on the star topology. Can we do that? Right? But let's look at this. Today's class, I'll teach you through the classful blocks allocation. Okay? But before we get into this, can you do do IP config in your Windows and tell me what is the IP that is configured in this particular LAN setup. All of you. Just go to IP config. Today we will understand there are three fields that you see there. First, tell me what is IP configured to this system that's connected in this LAN network. 172.16.80 எல்லாருக்கும் அது காமனா இருக்கா அப்புறம் the last byte. So do you think, okay, now what is a class you see there according to your understanding? If it is a classful block, it's a class C, right? Is it class C? According to your classful understanding, right, the range of IPs that belongs to class blocks what? 0 to 127 for class A, 128 to 191 goes for class B, right? 192 to 223 goes for class C. So yeah, but let's do one thing, okay? I want you to look at the subnet mask that you see there. Can you tell me what is the prefix length that you see? You're all able to relate to what I'm saying? Yeah? So can you look at the subnet mask value that's assigned there? And tell me what is the prefix length that is assigned to this network? 24. So it looks like a slash 24 block to you. Right? But let me tell you, this 172.16, 192.168 are all private IPs, which we could basically use, anyone can use in their own private networks. That's not going to be the IP that we see when you connect to internet. Because there's a concept called public IP. So VAT when it connects to internet, what do you prove? The IP that you see there is not the IP that you're getting connected to. So all these are private IPs that you can use. So now the point is, you all see that you have a slash 24 block that is allocated here. And typically we could use 256 hosts to connect, right? But then we only have 100 odd systems, 70 odd systems in this. So what I'm going to teach you now is, we'll first do classful blocks in our LAN allocation. Every LAN is going to use one class block, right? For example, I'm going to give one class C block for the LAN 1. Okay? Do you remember the prefix of class C? What's your prefix length for class C blocks? How many bits goes for the network portion? First 3 bytes goes for the network portion. So I'm going to give you what is the prefix length that we're going to use, prefix value we're going to use for this LAN, and this LAN. According to this particular case, what is the prefix that is fixed here? In this particular lab setup, 172.16.80. All of you see that, you will see that a prefix value is fixed. And every host here is identified with the last byte that you see there. So in our setup, let's use this private IP 1792.168.1. This is the prefix that I'm going to fix for this LAN 1. For this LAN 2, I'm going to have the prefix allotted as 192.168.2. And for this LAN 3, I'm going to allot 192.168.3. Right? Now there are separate three LANs, private networks, which we are going to interconnect. So what I'm going to do now is, I'm going to bring in a router, right? This router, do you see the third field that is there after your subnet mask in your IP config? You know what is this default gateway? Now from this network, I want to reach out to another network. I need to have a device which interconnects me to another network. And that device which helps me to deliver a forward the IP packet is going to be a router, because router is a layer 3 device. So we're going to have a router where one of the interface of the router you're going to connect to this network. Okay? So imagine you have your LAN port, you're going to connect to this network. There is going to be another interface, the WAN port. So I'm going to imagine that these three LANs are at three different campuses, right? And you want to interconnect them. So what we're going to do is we're going to interconnect this router. So what we're going to do is we're going to bring in routers to connect these internetworks, and let's look at how the packet routing process happens. Right? So let's do step by step. First, we will create the isolated LAN networks, right? And then we will go on with internetworking by configuring the routers and ensuring that they can be connected to the other networks. Can we do that? right? So this is going to be the high level task that we're going to do. So I want all of you to start Cisco Packet Tracer, right? Hope all of you logged in. So please, I hope all of you remember, choose your skills for all account and use your Google VIP account to sign in. You're all ready? Okay. So I've already signed in. Now, can I just to separate it, since we could build networks and we could scale up the design, just to have a visual appeal, I'm going to use three different blocks of class C as I told you. So just to differentiate the lands, I'm going to bring in colors for different lands, so that will give you a picture of the way that you're going to. There's something called as draw rectangle option. So click on this. We are not yet started the task. So choose this draw rectangle and then give a color whatever that you want for separate lands, just to give you a visual appeal. So I'm giving this one, and then you drag and place this, right? So this box I'm going to build say land one. Like that, I'm going to have separate visual appeals for different lands. Okay. Okay. And then okay. So the next thing that I'm going to do is, there is this option called place nodes. Yeah. So you can actually place your nodes by writing what class C block that we're going to give to these lands. So can you tell me what is the class C block that I'm going to allocate for land one? What's the prefix value that I told you? 192.168.1.0. Now, what do you mean? So, how many are able to see this? If you're not able to see that, so for land 1, we are going to use 192.168.1. You know the first 3 bytes for the prefix, right? So, this is the class C block that we're going to allocate for land 1. For land 2, let's have the prefix length as 192.168.2. What's the first address? Generally called? It's called the network address of that block. So what is that block for LAN 1? 192.168.1.0 is the network address. Right? For LAN 2, what's the network address? 192.168.2.0. And for LAN 3, 192.168.3.0. Okay? So I'm just, before we start building, you could place the notes. Okay, so let's do this. I want you guys to first separately build, the lands. So what we will do is, I hope you all remember your start topology that we did, right? Now, given one class C block, how many hosts I can use in that particular block or assign IPs? How many systems I can connect in this LAN one given this block? 2 to the power of? It's a class C block with prefix length 24. Now, which means I could use how many hosts are correct? How many hosts in that LAN? The last byte, 2 power 8, 256 hosts I can easily do that. But how many most effectively I can assign addresses are connected? 254. You know the first address and the last address, we don't generally use it. So I'm not going to ask you to build 254 hosts, but at least can you have 3 hosts or 2 hosts in every network? Okay, so what we will do is, we will first pull in a switch. Let's use the 2960 model switch. So place 3 switches in each of these LANs. Okay. Now these 3 LANs are not going to be like your VIP network. Here itself you have 3 LANs. It's going to be 3 separate campus where you have 3 LANs. Imagine like that. Okay. I'll tell you how we are going to do that. But then what we will do is we'll click on now end devices. I'm only going to show with one system. Yeah, 2960, first switch model. I think the first experiment that you did, we used the first model, right? So let me just pull in one system, but I hope you can at least have 2 or 3 systems in each LAN. In the LAN 3 alone, I want you guys to have a web server hosted in the LAN 3, right? So have a couple of systems and then bring in a server in the LAN 3. Is it okay? So you're going to build a star topology. So what you do is choose your connection, and I hope you all remember it. So in this connections, instead of going and choosing the cables, you could probably choose the first option, which is automatically choosing your connection type. So I want you guys to click on automatically choosing connection type, connect the end device to the switch, and repeat it for all the 3 LANs connected to the central controller. Is it okay? Okay. So now these are isolated LANs, right? What we should do now is to configure IPs to the system, right? So what can you tell me for this particular LAN 1, what's the IP that I need to start assigning? What's the range of IPs that I can start using for my host in LAN 1? Tell me the complete IP. 192.168.1 dot. You don't assign 0. From starting from 1 till 254 we can do. But I think I told you this rule, right? Generally, the second address in that block, we assign it to the default gateway. Who's the default gateway that we're going to bring in is, we're going to bring in one router here, which is going to be connected to the switch, and that router will connect to the next network. Is that okay? So, skip the second address. I'll tell you when we do that. So, starting from the third address, you could start assigning to the host. Okay? So, can you go and do that assignment here? So, what should I do in the laptop or the host that you have? Go on to the config, go to this interface of fast Ethernet, right? And tell me what's the IP. So go to this field IPv4 address and type 168.1 dot what? Yeah, we're going to skip out 1 because 1 I'm going to assign into the default gateway of the router. So starting from 2 you could do, and when you click on the subnet mask, you automatically see it's a classful block. It has taken the first 3 bytes for the prefix. Do you now understand the case here? Okay. So like that, can you do for LAN 1, LAN 2 and LAN 3 systems? Start assigning contiguous IP to the host of that particular classful block. You remember? So for the LAN 2, you should use what prefix? 192.168.2.2 and all that, right? Similarly, for the LAN 3, 3.2, 3.3 and 3.4. So at least have 3 systems or 2 systems in every LAN. LAN 3 alone, please have a web server hosted. So I'm going to just have one system here. All of you are clear? Any doubts? So I'm going to LAN 2. The prefix here is 192.168.2. Starting from 2, I'm going to start allocating. And for the LAN 3, hope all of you have at least 2 hosts in the LAN. Yeah, please have at least 2 systems. No, no. So you should not allocate the first address. Right? First address is for identifying the network address of that block. We will understand in the routing process. So the rule is don't allocate the first address and the last address. Second address, I told you we will allocate it to the default gateway of that network. We will bring in routers and configure. So starting from the third address, you could start using. So which means for the server, you want to give the third address, and the next one for the host, and that you could do like that. But you should remember what is the IP that you're giving. The first 3 bytes are fixed. So I'm now giving say 192.168.3.3 for the server, right? And whatever you want, you could typically give that. Okay, how many have done it? Fine. So now tell me, suppose any 2 hosts in a LAN wants to communicate within the LAN intra-network. Is communication possible? Yeah. So can you just try pinging and tell me how does the ping goes? Who handles the switching here? So go to command prompt and try pinging any 2 systems within your LAN and see if it pings. Ah, okay. One thing I want all of you to look at this is, do you see the port labels in yours? For every device, what is the port label? If you want to enable that, go to options. All of you please hold and look at the slide, this one here. Go to options and choose preferences option. Under preferences, can all of you please look at the board here? Under options preferences, there is an option called always show port labels in logical workspace. Can you enable that checkbox? Once you enable, you will see in which port your device is connected, right, through another device. For example, do you see the port labels now? Can you tell me which port is connected from your host to the switch? What is FA there? Just place your cursor on the laptop of the host. What are the ports you see in your laptop at your host? There's a fast Ethernet port, not even a fast Ethernet port, that's your LAN port, right? This is your Ethernet card, which can support up to 100 Mbps, right? So, from the LAN port, you are connected to what? To the switch, right? So, if you go and just place your cursor on the switch, look at how many fast Ethernet ports are there in the switch. This is a 24 port switch. Yes or no? But how many systems you have connected? Yeah, two. I was to two to connect, but effectively you can use 24 devices. But how many IPs in that block you could basically use? You have given one class C block for this LAN network. You could effectively assign 254 hosts. But your switch has a limitation. What's the limitation your switch has? Switch can only connect 24 ports there. You want to scale up, you can scale up by connecting to another switch and then expanding. But the idea now is I want you guys to understand that this particular network is capable of assigning up to 254 effective addresses. Right? So you can expand whatever that you want. But having said, you are able to ping directly from one IP to another IP in that block. Your switch basically handles at the frame level to do it. But my question to you is this, right? I want to communicate from one network, 192.168.1 to two network. From here to here, different network blocks, different devices has to communicate. Okay? So here what we're going to do is we're going to bring in a router and ensure inter-network communication is possible. Right? So let's now do that. How many have built this? Yeah, if you have built it, let's now get into the second aspect. I want all of you to look at the network device option. The first option that you click in the left hand most top pane, the first thing that you see there is the different models of routers. Do you see that? So if you click that, Cisco has different models of routers which are emulated here. I think for the lab we will do two kinds of routers. One, let me write it here. So there are two types of routers that we are going to use. One is called a modular router, right? And the model that we are going to use here, do you see a router number with 1841? Can you look at that router model? There are so many router models. Are you able to see this router model called 1841? Yeah. So just click that router model. In every LAN, place one router 1841. So for each LAN, we are going to connect to one router, which is going to connect to the other networks. Is it okay? Now this 1841 is a modular router. We'll understand what a modular router is. So we'll use 1841, and there is another model which is Cisco simulation perspective, which is actually called a Cisco router PT model. You see that PT model there? If you want, you can just drag and place it, but we will remove it. This is a non-modular one. So this PT router, just place and drag it. We will visually look at these two routers and understand what you mean by modular versus non-modular. Right? Yeah. No, no. You could just put it somewhere else to just to visually differentiate what is 1841 versus PT difference. But then we're not going to use it in the network design. Okay. So first thing I want all of you to look at is click on the 1841, right? And can you zoom in and see the router ports in this particular Cisco model? You see some vacant slots? Yeah. How many slots are there? So if you zoom it and see further, there is something called slot 0 and slot 1 where you can insert your interface cards. Right? So this is more of a modular router where you could scale up. Right? Whether you want to scale up with some fast Ethernet ports, LAN ports, or you want to have your WAN ports, right, to be connected, you could actually do this. It's quite a modular one where you could scale it up. By default, can you just place your cursor on 1841 and see how many ports you see in this router? How many ports you see? Yeah, so there is two fast Ethernet LAN ports that you see. You know what I'm going to do now is I'm going to add one extra card to support connection through WAN, right? Which means for long distance communication, you want to get connected to your ISP network or external network, we will use the WAN ports. So for that, all of you have seen this? I think meanwhile, if you want, you can go and look at router PT. Just place a cursor on top of it and tell me how many ports you see in router PT model. How many LAN ports you see? How many WAN ports you see? Yeah. So there are two fast Ethernet ports that you see, and do you see in addition some other ports coming in? So this WAN ports basically use serial communication. That's called serial ports, right? You can click that and see. Click your PT model, this is Packet Tracer Cisco model. This was simulation purpose. You will, if you zoom and see, you will see those WAN ports, which are having serial ports, which you could connect. So let me now build this modular router. And if you have seen that, you could just select it. We will probably use it in the next lab. We will scale up this particular router to have more ports. So I'm going to click on 1841 and we could insert modules in these empty slots. Okay? So I want you guys to look at the left hand side in the modules tab. There is something called as WIC-2T, the last but the third one. So what is the WIC-2T? You could look at the description at the bottom. WIC stands for your WAN interface card, and this particular card has two serial ports, two WAN ports supported. So you can have two WAN connections, right? And you can also have two LAN ports connections. You could scale it up like that. So I want you guys to just drag in and place it in slot 0. Tell me what's happening when you try to insert this card onto the slot 0. It asks you to switch off the router. So can you zoom in and power off the device? This is just to give you a feel of it. So just power off the device and then drag and place this onto slot 0. You see now there are two different serial ports that you can actually use it for your serial connections. But don't forget to switch on the module. Okay? So you know what happens is, I'm not sure how many teams really worked on the routers in your setup. Anyone tried? Oh, very good. So, in fact, what I'm going to do is, if you get onto any Cisco routers or even at the switch, Cisco basically, these routers have an iOS, which is called Inter-Network Operating System, right? And there is lakhs and lakhs of commands that you can issue, right? If you have to do that. So that action mode is called CLI mode. In fact, if you take your CCNA curriculum, it takes you to helping you to understand all the commands that you can issue, right? And configure for a router, enabling the protocols, and looking at what's the configuration and all that, right? But let's do this quite, step by step. Probably we'll understand the very base today, right? And then we'll get on into it. Okay. So, have you done this? Have you switched on? So when you switch on, the device boots up, your OS loads, and whatever is the configuration by default, everything gets reset. So you basically want to, load your configuration, setting IPs and all that. We'll go and configure all that, right? So I want you guys to do this for the other two routers by inserting your WIC2T module. Yeah, no, just one slot is enough. You're only going to use one WAN port. But I want you to repeat the procedure. I hope all of you turned on. Now, when you turn on and you get out of the CLI, you will see the device is booting. Right? When you turn on and power on the router and you switch to CLI tab, you will see your router gets booted up. Do you see that? Yeah. Anyway, let's not get into that now. I want you guys to do the same thing by extending the support for WAN interfaces. Don't forget to power on your device. Once you have done that, just place the cursor on all these routers. Now tell me how many ports your router has. The fifth one is VLAN, that you can leave it. So don't get confused by these numbers, right? You see fast Ethernet. What do you see in fast Ethernet? Something called 0/0/0/1. That first zero represents your slot number, right? And in that slot that you have inserted the card, there are two LAN ports. And so one is port number 0, another is port number 1, right? Like that, if you look at for your WAN again has two slots, right? So the slot number, the interface, and then the port number. The last number that you see is the corresponding port number of that particular interface card that you have. So let's not get confused. There are multiple ports now that you could use. Two WAN ports and two LAN ports. Are you all able to see that? Yes or no? Okay. So now can we do this? The main goal is to interconnect these two multiple networks, right? So I want all of you to do this. Go to connections, choose automatically, choose connection type, connect the switch to the router. Connect the switch to the router in all the three LANs. Connect the switch to the router. So it got connected to what port? Can you tell me? By default, you see that the LAN ports of your switch and your router is interconnected. Similarly, do that. I hope you're able to understand this, that the port 0, right, of your LAN port is connected to your switch, right? But do you think the interface is up and running? No. So we have to basically configure interfaces, and this particular router now has four interfaces, two fast Ethernet ports and two serial ports. Every interface you can connect to one network. But now this particular LAN interface, we have connected to this LAN block. So can I bring you back the role now? What is the interface IP that you will assign to this router interface? This router interface is connected to your LAN 1. What will be the IP that you will assign to this LAN, router interface? I told you the general rule is the first address is the network address. The second address, let us assign to the default gateway. So any system here wants to communicate to any other systems. He only relies on whom? He relies on the default gateway. This router is the one which can take your packet outside the network. You want to get into VIP, you have to come through the main gate. You want to go out of VIP network, you have to go through the main gate. It's like that. The router acts as a gateway for entry into your network and exit out of your network. From this network block to some other network block, your router has to do the packet forwarding. Is it okay? So every interface you need to assign one of the IPs in that block. Let's use a second address for that. Can you do that? So how do you do this stuff? Let's do it carefully. I'm going to teach you in the going mode, but we will slowly understand how it translates to the commands. So get into the router. Can you all carefully look at this, please? Get into the router. How many interfaces you see there? Four interfaces. Which interface we need to get now? Can anyone help me out? Yeah, fast Ethernet 0, port 0. That's the one it got connected, right? Click on that. Okay. Can you tell me what should I do now in this? Yes, go to the IPv4 and assign to that router interface point 1.1. Click on the subnet mask, right? Once you click the subnet mask, automatically your classful block prefix comes in. How many have done it? Okay, when you're doing it, I want you to parallelly look at the bottom command window. Whatever that you enter in the GUI gets translated to the command that gets applied. The direct command will கொடுக்கலாம், but I think we will learn like this. So what you're doing is there is command where you can get into every interface. This is the Ethernet interface of the router, and you're assigning the IP address for that interface. Are you okay? But please do not forget to do this. This switch and the router, if it has to forward and communicate, it has to be negotiated with what is your common data rate. So for that, what I want you guys to do is, if you look at, there is an auto negotiation process that happens to synchronize the transmissions, right? So I want you not to forget to turn on the port status of that particular interface to on. And when you switch it to on, it goes on to negotiate with the device that it is connected and decides on the rate of transmission. Which means what is the clock rate that you are going to operate and what will be the rate of transmission to synchronize. இது பண்ணும்போது you will see the LED interfaces turning to green. Are you able to see that? Turn the port status to on and you will see that there are commands applied and the interfaces becomes up. Which means what is the rate at which we are going to communicate is synchronized between these two devices. Have you done it? Okay, so if you have done the configuration of one of the interface, right? But I want you guys to do the same for these two routes. Can you do it? Yeah, please do it. Let's do step by step. Please understand and do. What will be the interface IP that will give to the router of LAN 2? 2.1. Here, 3.1. Turn the port status to on and all this. Okay, if you have done that, okay, how many have done it? Sorry, there's one more setting I want you to do in all the hosts, right? At least in one of the hosts, you have to do that. Whatever you want to ping and test. So let me go to the laptop, go to the config tab in this laptop, and go to the global settings. Clear? Now, I want you to fill the default gateway of each host in every network. Right? Now, can you tell me what will be the default gateway IP that this host should be configured with? Suppose he wants to communicate to other networks, he needs to send the packet to the router interface connecting to that. So, the default gateway IP will be 1.1. Like that, can you give it to the host in every network that you have? Who is its corresponding default gateway IP? So, I'm going to give only for one. Let's test with one device. So for my LAN 1 host, I'm giving the default gateway as 1.1. For my LAN 2 host, I'm giving the default gateway for him as what? 2.1. And for my LAN 3, I'm going to give it for both my server, For every systems in LAN, the corresponding default gateway is a router that connects to the external network. So understand that and do. Okay. Have you done it? So let's now get into the core of it now. Right. Can you now tell me whether I will be able to ping to the router this interface? Possible? Can you try pinging? Try pinging to all the systems within this LAN. You can even ping the router interface. You can ping the other system. See if it all works. You able to ping the default gateway? Yeah. Are you able to ping the default gateway? What is the default gateway? One from here to 192.168.1.1. Right? What happens? The switch basically understands that this interface is mapped to this port, and it basically forwards it. Now let me tell you the command that you can issue to the host to see its routing table. Host will also maintain a routing table. The routers will also maintain the routing table. But what is the command that we're going to learn now? I want you guys to issue this command. Can you go and type this command called netstat space -r in your host? This command holds good for the host in the network, which -r means you're printing the routing table. You're printing the routing table of that particular host. Netstat is network stats. So now can you tell me how many entries is there by default in the host routing table? What is the table entry you see there? How many were there in the morning class? Yeah. So do you remember? And what's the entry you see there? So let me paste this whatever that I get here so that everyone can see it. Okay, anyway, it's not coming. What's the first column telling you? Are we individually storing the host IP entries? No. What we generally store? The network address. Right? But now the host by default has only one entry. And what is the entry that you see there? 0.0.0.0. Do you see that? What's the mask value that you see there? Again 0.0.0.0. And what is the interface that you're sending or the gateway that you're sending? Gateway meaning the next hop. Right? Who's the next hop? Who's the gateway now? By default that you're going to send is this router interface. Now what does it mean? How many remember the switch case statement that I told you in the theory class? None of the entry matches. You have to forcefully ensure that it matches the default. Here there's only one entry. And what's the mask value? Mask value is 0. So when you take any IP in the packet and you do a mask, right? It will match with your network address, which is 0.0.0.0. So what it will do? It will forward the packet to this router interface. So it relies on the default gateway to take the packet out of the network. You understand this? So host has this routing table, but now let's interconnect the routers. And how we're going to interconnect is these are three different networks. We're going to use the WAN port to connect to the other devices. So let's now do this. Have you done this? Netstat command. You can take the screenshot of that and keep it. But here is where the entire game comes with respect to packet routing. So again want you guys to choose automatically choosing your connection type and connect the router of LAN 1 to LAN 2. Right? Similarly, so let's do this first. Don't try the next one. Let's understand this. Right? Now generally WAN connections are long distance links which connects to any external networks. So just to show you that this link is a long link, it comes like this as a representation for you. So you're connecting two separate networks, and through WAN, there's a separate communication protocol through serial communication to establish a point-to-point connection between these two. But now, look at which port it is connected to. Can you tell me which port number? Serial port 0, right? Of this. You can just place your cursor on this, right? And see that we need to configure this serial interface 0/0/0. So how do we do that? Let's look at this. Now I want you guys to understand this, okay? This two interface I need to assign an IP. So let me give you another block for this interface. Similarly, these two routers we are going to connect, we are going to give another block of address. Just for understanding, we keep continuing. For example, 192.168.4.0.5.0 we can give like that. But just for a differentiation, I'm going to use same 10 block for this particular interface. Similarly, 11 block for this particular interface. I'll teach you for this, you repeat for this. Okay, so what we now do is, can you tell me what's the first address in this block? According to your 10 block is which block? Which it's a class A or class A, right? Now tell me what is the first address of this? Okay, that's the block address. What's the next address? Second address will be 10.0.0.1. So let me assign 10.0.0.1 to this interface and the next subsequent IP to this interface. Is it okay? I'm taking two addresses from that. I'm going to assign it to the two router interfaces. Is it okay? So let's do that now. How do you do that? Is go to the router. Tell me which interface we need to go now. Serial 0, right? The first one. And can you enter the IP that I told you? What's the IP that you're going to enter? 10.0.0.1. So this interface is going to be connected to that interface of that router. Both belongs to the same block. Okay. So can you click on the subnet mask and see what is the subnet mask? So you see a default class A block subnet comes now, a block comes. Now, before you close this, can you switch on the port status to on so that this interface it start to synchronize with that router, right? So by default, you see the data rate, clock rate to be 2 Mbps. So just turn on this, but we'll have to go and configure that interface, and then you will see your interface becoming up. Can you do that? So what you should do now, having done here, I want you guys to go to this second router. How many have already done for the fast Ethernet port? In the router 2? Yeah. So can you go to the serial interface? Which serial interface you have to go? Port 0. Right? So the port label will help you to do that. What is the IP that you're going to give to that serial interface? 0.2. Can you do that? Click on subnet mask, switch on the port status to on. You will see the serial interface is changing the state to off. Do you see that? Okay. And you should see the LEDs of these interface turning to green. Right? There are multiple cases where you will have issues. One, if you have not switched on the port status to on. Second, if your device is not powered up, obviously the interface is all down. You will not be able to communicate. Right? So ensure that you do all that. And if you have done this, can you repeat this for the router 2 to router 3? Again to WAN port. What is the block I am asking you to assign to this interfaces? Yeah, so 11.0.0.0 is the block address. Can you do that please? So understand which is the port number and accordingly go and assign the IP to those interface. Anyone has any doubts in these steps? Are you clear? So how many interfaces we have configured in the first router? How many interfaces are configured in the first router? Two interfaces. How many networks this router is connected to? Who are their directly connected networks? This router is connected to this network. What is this network address? 192.168.1.0. This interface is connected to which network? This interface. What is the IP that you've given to this interface? So this is 10 network. Yes or no? Now go to this router, middle router. How many interfaces this middle router has? Three interface. What are the three networks it is connected to? 10.0.0.0, 11.0.0.0, 192.168.2.0. Similarly, this router has two networks. Right? Now tell me, any host in LAN 1, will it be able to communicate to LAN 2 or LAN 3? Can you ping and do and tell me whether they are able to get the connection established? For example, ping say from 192.168.1.1 to 192.168.2.1 or 2.2. I'm sorry. Right? I'm assigning from 2, right? Do you think the ping is successful? What do you get? Do you get request kind of? You are getting something else. What are you getting? Okay. How many are getting this? Destination host unreachable. Why you get that particular output? Yes. You know where is the problem? Now this guy relies on whom to reach out to this networks. These hosts in this LAN. Switch will only take you to this within this. அவ்வளவுதான் எந்த போர்ட்ல எந்த டிவைஸ் மாப்பா இருக்கு மட்டும் தான் switch தெரியும். Switch will not know other networks. It's a layer 2 device. Okay. Now tell me, these hosts rely upon whom to take it to the other networks. It relies on the default gateway router. But this router should know, right, where I should take the packet next. Anyone is that? What you should do now? You should go and look at the routing table of these routers, whether they have the knowledge. By default, you have not fed any knowledge. You have not enabled any protocol or you have not manually entered the routing table entries. So today we are going to learn how to do static routing. Did we see that in the class? Static routing is how you manually add the route information. So yeah, so let's now look at this. All of you have done this? You're getting destination host unreachable. Take the screenshot of that. But let me now teach you how let us add static routes to these routers to teach that. Right? So can you go to the router 1? You're all there? Okay. So I want you to choose. Do you see the routing tab there? Yeah. In that routing, there is this option called static. So today's lab, we will learn how to add routes manually. Okay. Can you tell me what the routing table contains? What are the columns? Do we store the host IPs? We actually store the network address. Very good. What's the next column? Mask value. What's the next subsequent columns? Who's the next stop if you have to reach out to this? In the information we are going to manually create. Now tell me, help me out that in this router, what is that I need to teach him? He is directly connected to what? He is directly connected to 192.168.1 and 10. That's the knowledge he has. Does he has the knowledge of how to go to 192.168.2? So what you should tell him? Hey, come on, yeah. If you have to reach out to 192.168.2, whom he has to send next? This router, if he gets a packet to reach out to two network, this router has to send the packet to whom next? The next router interface that he is connected to. What is router 2 interface that he is connected to? What is that? 10.0.0.2 convert partial next stop information need to be. Similarly, if I have to reach out to 192.168.3, whom should I say next? Again, the next router only. I'm only connected to the next router. What is the IP of the interface? 10.0.0.2. So, either NPR from top. We're going to add two different networks block address in this routing table. So how do you do that? Go to the network network field and add the network address. What's the second block? 192.168.2.0. Let me write it here for those who are not able to see. So add this entry in the network and 192.168.2.0. Can you help me out in the next field? What should I add in the next field? What's the mask value for this? You know this is a class C block. So what should I do? 255 dot 255 dot 255 dot 0. Yes or no? Okay. And the next field, can you help me? We are adding the entry in the routing table. What is the next stop that I need to give? 10.0.0.2. Can you add two entries like this? So what you do is fill in those fields and click on add. I want you to observe when you add, what is the command that gets translated? Parallelly, you will see in the CLI that there is a route that is being added in the routing table, right? And the route information is the network address, the mask value for that, and the next stop. Similarly, add one more entry. You have added that in the table, right? Next entry should be what? 3.0, right? Again 10.0.0. Sorry, how many have done this? Okay, so now do you think you'll be able to communicate a two network? Can you now try pinging from host 1 in LAN 1 to say host 1 in LAN 2? Does it work? Work kada illiya? You added the routing table entities, right? Which routing you added? The first routing you added. Can you now ping and tell me whether you are able to get a reply? How many are getting replies? Destination host country should work, huh? Varala. Request time not work. Can you tell me the reason behind this? Okay, then routers we have fed this knowledge now. Yeah. So the first router has a knowledge. It directs the packet to the next router. Does the router has a knowledge? Right? In fact, he has a knowledge of the two network that he is connected to. But another reply in the one network திரும்ப வரணும். But the reply வரணும்னா ரெண்டாவது router தெரியாது. So what he should do? He should send it to 10.0.0.1. அந்த entity நீங்க கொடுத்தாதான் அது தெரியும். Are you able to understand this? Yeah. So this is not. No. Let's look at this. There are two cases here. This particular block is 10 block. So this is 10.0.0.1, this is 10.0.0.2. இங்க ping பண்ணும்போது these are the things that are involved. Right? Can you not try pinging from this to this without adding any entries? Are you able to ping to 192.168.3.2 or 3? This time are you getting again request standard or something else? The destination host unreachable or the A destination host unreachable or something? This guy knows, right? If you have to send it to 3, you only told the information. What did you tell? If you have to reach out to 3 networks, send it to router 2. But in this router knows the knowledge of 3 networks. He only knows the knowledge of 2, 10 and 11. அப்ப இவன்ட்ட நம்ம information கொடுத்தாதான் அவன் இவனுக்கு அனுப்ப முடியும். Correct? So if any router does not have the root of a particular network, it will give you destination host countries, right? But then the reply timeout comes. And the reply packet does not know, the router does not know where to take the reply packet. So what we should do, what's the moral of the story? Go and feed the routing table information for router 2 and router 3. In router 2, what is the routing information that you're going to add now? Let's see how many have understood this. In the second router, can you tell me what are the networks that the router 2 is not aware of. Okay, before you add all this, you know how many have done till this month? Okay, I want all of you to please hold and look at the board here. I'll tell you how to look at the existing routing table of routers. Post என்ன command கொடுத்தோம்? Post உள்ள routing table பார்க்கனா you gave next step, right? But then when it comes to Cisco routers, right? The command that we're going to do is I'm going to take you to the CLI. All of you please. I'm going to take you to the CLI mode. Click on the CLI mode. Right? I want you to scroll through the commands that are already executed and go at the bottom. Are you in this particular case? Let's look at this. I want all of you to look at this. You are in this mode called configuration mode. Are you like this? Okay. Can you issue this command called exit? Okay. So when you click exit and press enter and enter again, you will be getting onto this mode. Are you there? In this mode. So again you give exit. Where are you now? So press that to do that. I'm doing that because I will not be able to see what I'm doing in the case. So now you will be in this mode with this arrow, right? Yes or no? Okay, so this mode is called user execution mode. So by default, when the router is booted, you want to configure the interface of the routers. You will have to get into a mode called global configuration mode, right? But then you need to have the privilege to issue those commands. So now, all of you please, I'm going to just teach you two commands, right? In this mode, type this command called enable. Can you please type enable? When you type enable command, you will get into this mode, which is called the user privilege mode. Have you got into this? Yeah? Okay. Now, in this user privilege mode, you can look at what is the configuration being done. For example, you can display the routing tables, right? All this you could look at. What is the IP assigned and all that you can look at it. So this is, you could do it only in the user privilege mode. And there are lots of commands, and those commands that you want to see, it starts with this command called show. You want to show the, yeah, you want to show the routing table, display the routing table, you can issue show, right? So can you give this command please? Show space IP space root. All of you, please issue this command. Show space IP space root. This is the command that you issue in the router to display your routing table. ಎಲ್ಲರಿಗೂ ತಿಳಿದ routing table? Are you all there? Do you see your routing table display? Can you tell me how many entries are there in that routing table? Show space IP space root. How many entries you see, ma? Okay, can you tell me in the first column there is some symbol that comes, right? You know what the C means? Can you look at what is the description of C there? Those networks are directly connected networks. The router is directly connected to which networks? Can you tell me? But router R1 was directly connected to the two interface was connected to two networks, right? What are the two networks you see which are directly connected? 10 network and one of the interface of router is connected to 192.168.1.0. Those two are directly connected. But now how many routes you added manually? Two networks, right? What is that entry you see? You see the yes there? Yes means what? Static entries. Now you have added two manual network entries. And what are the entries you added to the router? What are the entries you added to the router, huh? This particular R1 you added telling if you want to reach out to 192.168.2.0, you need to send to whom? 10.0.0.2. That entry you see under yes. Similarly, 3.0 if you have to send, who you have to send next? 10.0. See these two entries you have added manually. So there are totally four entries. Two directly connected networks it knows, but it does not know the indirectly connected networks. Those information you have added. But have you added in router 2 and router 3? So I want you guys to now go and feed the necessary knowledge that the router 2 should know and the router 3 should know. Can you tell me what networks you need to add in router 2? How many understood this? Yeah. So now router 1 you have added. Go to router 2. Can you tell me what are the directly connected networks of router 2? Ah, 11.0.0, 192.116 or 2.0. What knowledge he does not have? He does not know about one network. He does not know about three network. If he has to go to one network, to whom this router has to send? To this interface of this router, which is 10.0.0.1. So add an entry telling if you have to go to 192.168.1.0, send it to 10.0.0.1. Another entry என்ன add பண்ணணும்? What's the second entry? You want to send to 3.0, send it to 11.0.0.2. How many understood this? If you understood this, then you fit the knowledge to this router manually. Similarly, go to router 3 and add the necessary entries for router 3. Your task starts now. I want you guys to fill the routing table of these two routers, and I'm going to give you test cases to test. Right? Can you do that? Once you've added, please print the routing table. Yeah, please print the routing table and see whether you are seeing the static rules added properly. Yeah, how many have heard it? Please take the routing table. So your time 10 minutes starts now. So I want you guys to test the following cases. Okay, if you have done, can you first test the first four test cases I'm giving here? Okay. Combinations from LAN 1 to LAN 2, LAN 1 to LAN 3, right? You need to test pinging. I need the screenshots to be collated and finally you can show to your scholars. So similarly from LAN 2 to LAN 1, LAN 3 to LAN 1, are you able to establish the communication? Right? If you have done your settings properly, feeding the routing tables is one thing. Second is reply request and not backward. Right? Every host should know who is the default gateway, number one. And the routing table should be correctly populated. Finally, if you have passed, all these four test cases should pass. But I want you to try these two test cases also. LAN 1 learn there, I want you to ping to R2 interface. Similarly, LAN 1 learn I want you to ping to R3 interface. Now, what is router 3 interface? 11.0.0.2 ping padunga. Similarly, 10.0.0.2 ping padunga. See whether you are getting replies for this. Let's see how many can finish this 6 and you tell me which will fail. Is it clear? or your device is powered off. Now first rectify it, right? So which one is I want you to think. See, the question that I asked here is, in the laptop library, can I ping this interface from this host one, say in LAN one, from here to this router interface? Will the ping be work? Will the ping work? From this host to this router interface, what is the IP that I assigned to this interface? 11.0.0.2 this interface, right? இங்க வந்து 10.0.0.2. இது ரெண்டு கேஸ் ஒர்க் ஆகுமா? I want you guys to analyze and tell me if you have got the outputs for all the 5 test cases. In fact, 6 test cases. So what I'll do is I will put it in the LMS. If you want, you can download. But the logic is this: LAN 1 ல இருந்து LAN 2 ping பண்ணுங்க, LAN 1 ல இருந்து LAN 3 ping பண்ணுங்க. Vice versa. LAN 2 to LAN 1, LAN 3 to LAN 1. Right? Both way communication should be possible. Anyway, those test cases I have uploaded in LMS. In case if you want to see that, you can see it. How many have tried the first 4? How many got it working? Okay, how many are getting request sent out, destination host unreachable? If you're getting destination host unreachable, the reason is the routing table entries in the router are not entered correctly, or it's not entered. Request sent out பண்ணுங்க அப்படின்னா, look at whether the reply is coming, right? You can use this command. I think how many remember this command called trace RT? You remember this command trace RT? It will trace the route it takes. Into my நிக்குதல் பாருங்க. You can understand in which router it stops and why it does not come. This could also be used. Anyway, let's take the attendance. If you have got, how many got the 5th one working? Good. Anyone tried the 6th one? You know why it is not working? Can you debug and tell me? You're trying to reach out to 11 network. No. If anyone can debug and tell me why SK6 is not working, you'll get full marks for this lab. Anyway, just to motivate you, but try seeing if you can find out the reason for this case alone not working.